Welcome to Brain Vision.
So here in this problem we are given this aircraft, as you can see here, and this aircraft is able to take 4.5 meter cube of volume in a 12-second run. So this one is the volume of fresh water, and time taken to take this volume is 12 seconds. Now the velocity of the aircraft during the intake of this water V is given to be 280 kilometers per hour, and the initial mass of the aircraft we are given to be as 16.4 megagram. Now as the scoop enters the water, the pilot gives an additional power of 223.8 kilowatt to prevent the deceleration. Now we have to find this initial deceleration during the scooping action as a scooping action starts. So this is what we are given in the question, and to solve this problem we'll be using the variable mass concept, or you could say the variable mass approach. Now here we observe that for constant initial speed, the propeller thrust that is given by provided by the engine, it should be equals to the drag force R, this value, and added power by the pilot we are given to be as 223.8. So thrust would be equals to, from here we know that power is equals to the thrust force times the velocity. So from here we can calculate this thrust force. So power we have 223.8, and the unit is in kilowatt, so we can convert it into watt by multiplying it with 10 to the power 3 is equals to this T times the velocity, and velocity we are given as 280 km per hour, so we can convert the units into meter per second. So 280 times 1000 divided by 3600. So from here the thrust force that is equals to this reaction force, or you could say the drag force R, will be equals to 2880 Newton. Now we can apply this variable mass approach, and we can write that sigma fx in x direction is equals to mv dot plus m dot u. Now let us first calculate the mass flow rate for water. So m dot would be equals to the density times the volume divided by the time. So density of water we have 1000 times the volume of water is this much. This is basically volume. So volume is 4.5 meter cube divided by time is 12 second. So m dot would be equals to 375 kg per second. Now we can put the values here. Sigma fx we have R, that is equals to 2880 Newton, and it will be equals to m, that is the initial mass for the aircraft, that is this much. So we can write this thing as 6.4 times 10 to the power 3 kg times v dot we have to calculate, plus m dot is this much that we have calculated, so 375 times u, and u in this case would be equals to this velocity 280 km per hour, and if you write this unit and the velocity in meter per second, it would be nearly 77.8 meter per second. So from here we can solve it for v dot. V dot is basically the deceleration, and its value comes out to be as negative 1.603 meter per second square. So this would be the deceleration during as the scooping starts. So this is the final answer. I hope you have understood the problem. Thank you.